Assalamu alaikum wa rahmatullahi wa barakatuh. In this lecture, we are going to talk about the matrices. First of all, we will know its definition and its type of matrices, and then we will discuss some operations that I can do with matrices, like adding matrices, subtracting, multiplying, and so on. Why we study matrices? Um, if you study already the determinant, you will know the Kramer rule. You can use the determinant to solve an equation system, like two equations with two unknown. It will be a bit harder to make 3 by 3 equation, but it's okay. And if the unknown increase, this will make the problem is difficult to solve. In this case, we can use matrices. So matrices also can be used to solve an equation system. What is matrix? A matrix is a rectangular array of variables or constants. So the matrix can be variables like x, y, a, b, c, and so on, or constant like 6 to 0, minus 2, and so on. These elements or these variables or constant are arranged in horizontal rows, as we can see in this matrix here. In the first row is 6 to minus 1, so these constant are arranged in horizontal rows and vertical columns like 6 minus 2, 2 zeros, 2 0 minus 1, 5, enclosed in square brackets. We use the brackets to enclose the matrix element, while in determinant we use a vertical bar. So if the elements between vertical bars like here 2, 4, 0, 3, this is a determinant enclosed between a vertical bars. But if we enclosed these elements between brackets like this, it will be a matrix. And the matrix has something we called dimensions or order. As you can see here, 2 multiplied by 3. It's the number of rows. How many rows here? This is the first row, and this is the second row. So we have 2 rows. So the dimensions here is 2 by 3. The 3 is number of columns. So we have here the first column, the second column, the third column. So it's 2 by 3, number of rows times number of columns. So the element, each value in a matrix either was a number or a constant or any variables like x and y and so on. It's called element. The element, each value in a matrix, either a constant or a variable. The dimension, as we said, is the number of rows times or by numbers of columns. A matrix is named by its dimension, so we always will say matrix A 2 by 3, matrix B 1 time 1 by 5, and so on. As we can see in this example, we have a matrix A. This matrix have elements. The elements here is 1 a 1 1. 1 1 here, it means the first row, first column. Then a 1 2, 1 for the first row, 2 is the second column, and so on. Here a 2 1, 2 for the first row, 1 for the first column. A 2 1 to the second row, 1 is the first column, 2 2 to the second row, the second column, then 2 3 2 4, and so on till we have a m1, the m here for number of the row, 1 for the column, and so on. So each element can have his own definition. Two numbers, the first number for the his location in which row, and the second number for the column. A matrix is an array of numbers, or as we said before, or variables, or constant, and so on. Here, denoted with a capital letter. We always use a capital letter for matrix, and we said it's enclosed between brackets, square brackets. All matrices have an order or a dimension, and as we said before, the order or the dimension is number of rows by number of columns. That is a number of rows time or by the number of columns. So in this example E here have 2 rows and 3 columns, so it's A is 2 by 3 or 2 by 3. Let's have some examples here. This matrix A, we want to know its dimension or its order. As we said, it's about number of rows, so we have here 3 rows, so it's 3 by number of columns. Here we have 2 columns, so it's 3 by 2. So its dimension or its order 3 by 2. The matrix B, number of rows 1 2 3 4, so it have 4 rows and 1 column, so it's 4 by 1, and so on. Here 2 by 1 2 3 4, so it's 2 by 4. So about the types of matrix or matrices type. The first type is a column matrix. A column matrix is a matrix with just one column. So it's a matrix with only one column and any number of rows. So it can be one column, and here we can 1 2 0. In this case, this is a column matrix with one column but 3 rows. It can be 4 rows or 2 rows and so on. The row matrix, a matrix with only one row and any number of columns. So 0, -1. Okay, let's make it only 2 columns. Of course, it can have any number of columns. So the row matrix is a matrix with just one row. A square matrix, if the number of rows equal number of columns, so it will called a square matrix, a matrix that has the same number of rows and columns. So M, which indicate the number of rows, time n, which indicates the number of columns. It will be 2 by 2 or 3 by 3 and so on. We also have special matrices like diagonal matrix. Diagonal matrix can be classified to upper diagonal matrix or lower diagonal matrix, and null matrix and identity matrix. The diagonal matrix, as we can see here, it's all element equal 0 except the main diagonal. So all elements of the matrix equal 0 or 0 except only the main diagonal. So a diagonal matrix is a square matrix that has values on the diagonal with all of diagonal entities being 0. So it's all element equal 0 except the main diagonal, and it's a square matrix. If this main diagonal consists of any number like 5, 5, 5, 5 or 8, 8, 8, 8, minus 1, minus 1, minus 1, minus 1, and so on, it will be a scalar matrix. And if the main diagonal is unity or equal 1, in this case we will call it identity matrix. So diagonal matrix can be just a diagonal matrix if A11 and A22 and 33 and so on are not equal. If they are the same number, it will be a scalar matrix. If the main diagonal consists of unity or of 1, it will be identity matrix. So as in this example, this is identity matrix. Identity matrix denoted by letter I. Usually we refer to the identity matrix with I. So this I4, because as we said before, diagonal matrix is a square, so we don't need to say 4 by 4. It's I4, it means it's order 4 by 4, and I means its identity. An identity matrix is a diagonal matrix where the diagonal elements all equal 1. We will talk about the matrix multiplication. Here give us a rule. If we have a matrix A times I, the matrix identity matrix, the result will be A. So any matrix times identity matrix equals the same matrix. Null matrix, of course, is a square matrix where all elements equal 0. Null matrix is a matrix, square matrix with all, so it can be 2 by 2, like here, 0, 0, 0, 0, or as in here 1, 2, 3, 4, it's 4 by 4. So as we said before, diagonal matrix, a square matrix which have all element equal 0 except the main diagonal not equal 0. A scalar matrix is a diagonal matrix which have the principal diagonal consists of the same scalar. As we said before, if we have 2 by 2, it will be 2, 2, 0, 0. This is a scalar matrix, or it can be negative 1, negative 1, of course 0, 0. this is negative 1. Eraser, negative 1. The symmetric matrix. A symmetric matrix, a matrix A such that AT here, AT mean the transpose of a matrix. AT or A power T here is referring to the transpose. Transpose, we get the transpose by interchanging rows and columns. So if we have matrix C equal 1, 2, negative 1, 5, and we want to get its transpose, as we said, it will donate it as C T or C dot, but here we will use CT equal. We will interchange or change rows to columns. So the first row 1, 2 will be the first column. So instead of being a row, it will be a column. So the first column will be 1, 2. The second row, negative 1, 5, will be the second column, negative 1, 5. So interchanging rows to columns will give us the transpose. Or the columns, the first column, 1, negative 1, will be the first row, 1, negative 1. The second column, 2, 5, will be the second row, 2, 5. If the matrix equal the transpose, in this case we will call this matrix as a symmetric matrix. So, as in this example, 1, 2, 3, 2, 4, negative 5. Let's erase this example and try to get the transpose of this determinant as a matrix. As we said, the first row will be the first column, 1, 2, 3. The second row, 2, 4, negative 5. The third row, 3, negative 5, 6. As we can see here, 1, 2, 3, 1, 2, 3, 2, 4, negative 5, 2, 4, negative 5, 3, negative 5, 6, 3, negative 5, 6. It's the same matrix. So the matrix A equal its transpose AT. It's the same matrix. So we call this matrix as a symmetric matrix. It's some kind of revision. As we said before, row matrix, a matrix with only rows like this one, 1 row, 4 columns. A column matrix, a matrix with only 1 column and any number of rows, as in here, 1 column, 2 rows. Square matrix, number of rows equal number of columns, 2 by 2, as in here, or 3 by 3, 4 by 4, and so on. Null matrix or zero matrix is a matrix consists all of its element equal 0.